In the previous video, I observed that the models folder contains an entity data model that really serves two purposes in the application. It's both our persistence model of our application, allow us to do that CRUD operation stuff on product, and it's also the presentation model, or rather what's called the view model, which we use to pass data between the controller and the view and back. Is that how we should always architect ASP.NET MVC applications? Do we always break the separation of concerns principle by munging those two concerns into one set of classes in our application? Well, if not, what the heck are we supposed to put in that models folder? All right, so allow me to start at a high level and talk about all this. Unfortunately, the term model is overloaded. It can mean different things based on the context. So let me suggest that there are several different types of possible models within an application's architecture. The first type of model belongs to the persistence layer of our application. If you recall the C# fundamentals via ASP.NET Web Form Applications course, we created an entity framework, entity data model in our persistence layer and kept it abstracted away behind the repository classes methods. We only communicated out of that layer using data transfer objects from the domain layer. So the next layer, or the next model, is the domain model. As we've often said, the domain layer contains the core logic of our application and includes a domain model that describes the major concepts of the application. Now, if we're building an application to manage customers, we might have concepts like customer, company, address, phone number, account manager, sale, and so on, represented as classes within our application. Now, sometimes the classes and the properties map one-to-one with the tables and columns in our database, or they map one-to-one with the data model and possibly one-to-one with the data transfer objects. Ideally, these are not just classes with properties, but also contain some methods that can perform operations on their own data. So the domain model, as we've said before, is the most important of all the models in the application, because everything else in the application can be replaced, but replacing a domain model essentially means that the company is fundamentally changing the way that they do business. Then finally, at the presentation layer, there is a model called a view model. Again, the classes and the properties of the view model could map one-to-one with the domain model and database tables and columns and the persistence layer model data, at least in simple applications. But the view model is more concerned with the shape of the data as it'll be utilized in the presentation layer. In other words, just because the classes and the properties take one shape in the domain model doesn't mean that they'll be displayed in that same manner to the end user in the presentation layer. The requirements of your business may demand that a given view include properties from multiple classes in the domain model. In this case, you'd want to shape the view model as it's used in the view. In other words, you would recreate new classes that combine the properties from several other classes in the domain layer for a particular view. You combine them all into a single class, and then you allow the orchestration between the presentation and the domain layer to kind of sort it all out. So the controller would make a call into the domain layer, get all the data that it needs, shove it into the view model, one class that it can then pass out to the actual view. So to recap, there's a data model, a domain model, and a view model. These could look identical in a simple application, but they could be shaped differently if the view requires properties from many different classes in the domain model. Now, I say all of that to say this. The ASP.NET MVC 5 application structure that comes out of the box whenever you do File, New Project, and you select MVC, it doesn't force any given implementation of which model that you actually put into that models folder. In fact, you really don't even need to use the models folder at all if you don't want to. You can create another folder and use something else. There's nothing magical about that folder. However, you're typically going to take one or two approaches with the notion of a model in an ASP.NET MVC application. First, you're either going to combine all of the models into one Uber model like we've done in this application. So putting the entity data model in the models folder, then extending it with the metadata like I demonstrated in the previous lesson. This is a form of the tools-driven architecture in so much that you're mixing concerns and allowing the tools like the entity data model designer and the built-in Visual Studio code generators to quickly build an application essentially for you. Now, in my personal opinion, this is only tangentially better than using ASP.NET Web Forms and using server controls to data bind directly to the database. However, it is quick, and you can do some unit testing, so it's probably a little bit better if you want some of the benefits from both worlds, tools-driven and maintenance-driven. Now, the second approach that you might choose if you're going to use that models folder is that you're going to separate all of the models out by their concerns into their own projects in your solution. And then those layers of your application would communicate to each other, with each other, between the layers using data transfer objects, DTOs. And so this is akin to what we did in the C# fundamentals via ASP.NET Web Forms applications near the end where we actually created separate projects for each layer. That's what we would do here too, and the MVC5 application would just serve as the presentation layer of the application. So in that first approach that we talked about where we munge everything together, we demoed in the previous video where we mix the concerns and utilize the entity data model as both the persistence model and the view model. And so in this case, whenever we use the term model, we're stacking the term model to mean that we're going to start with an entity data model and then we're going to bolt on the side those data annotations and turn it into a makeshift view model as well. The second approach that we talked about, that would mean that we would create a dedicated view model and then we would apply the data annotations directly to the view model. Furthermore, we would relegate the data model to a separate project in our solution and it would provide the persistence services to the application's architecture, specifically the domain model or the domain layer of our application. So the domain model would reign as central, the organizing principle of the application's architecture once again. So, perhaps whenever we build a really large application or fairly large application near to the end of this course, we're going to see the second approach in all of its glory. However, for now, since we've started going down this road for this Acme example of combining all the models into a single model of our application, we've taken a decidedly tools-driven approach, allowing ourselves to be seduced by the simplicity of Visual Studio's dialogues and code generation. But back to our original discussion, the discussion that kicked off this entire conversation about application architecture. We were talking about adding a partial class, a metadata class, like we did right here, so that any changes to the entity data model would not blow away the data annotations that we added to each of the properties of that class. And so we wouldn't need to go to such lengths, frankly, if we architected our application around a more traditional layered architecture, including a dedicated view model and a dedicated persistence layer, persistence model. We could simply add the data annotations directly to the view model's class properties because there's no chance that it's going to get overridden and that we'll lose those data annotations whenever we update the entity data model in the persistence layer, because again, it's a whole other project. We don't have to worry about it blowing it away in our view model. Okay, so let's recap a couple things that we've said here. First of all, the term model is overloaded and you need to get clear on what the term means to your particular application's architecture. It might be used in several different contexts, so don't just use the term model, use the term that best describes it. This is the domain model. This is the entity data model that lives in the persistence layer, so it's our data model. It is our view model, and so on. Okay. Secondly, in a maintenance-driven architecture where concerns are separated, you'll have many models. A data model in the persistence layer, a domain model in the domain layer, and a view model in the presentation layer. Third, in a tools-driven architecture, there may just be one model that's asked to do double duty as both the data model and the view model. Therefore, applying data annotations to it requires us to be careful lest we add our code into generated code and lose it once we regenerate the entity data model and Visual Studio's T4 templates blow it away. When we generated an entity data model in the models folder of our ASP.NET MVC project, we were mixing concerns, which is typically a no-no in maintenance-driven approach and maintenance-driven architecture. The entity data model is serving at least two purposes in our case here. It is both the persistence layer of our code, and we add data annotations. When we do that, we're turning it into the presentation model as well, or the view model as well. Now, if we want to build a maintenance-driven architecture for our application, we should really split out the persistence and the domain layers into their own projects within our solution. Hopefully, I'm not beating a dead horse here. So as we've learned, this will allow us to replace the ASP.NET MVC functionality, the ASP.NET MVC presentation layer, with a Windows Forms-based presentation layer if we want, a universal Windows platform application-based presentation layer, or even a web API layer that's used by iOS or Android presentation layer. Okay, so that's one of the benefits of the separating the concerns out into different layers of our application. We can reuse it in a lot of different contexts. Okay, so hopefully all that made sense, and now we're clear on what models are and what they aren't, how they're being used here, how that's a little bit more tools driven, how I am preaching the gospel of separation of concerns and a more maintenance driven architecture, especially for large architectural applications. But if you're going to ask me, well, what's the right way to do this? As in all things with application development, the wise developer says, it depends, right? All right, we'll see you in the next lesson. Thank you.